Hey, I am glad you're here. This is Eterna Mind, short but deep journeys. Let's begin. Our planet's last great frontier isn't a jungle or a mountain, it's the ocean. Oceans cover over 70% of Earth's surface. Their average depth is about 3.7 kilometers, but in a few places the seafloor plunges so far that it could swallow our tallest mountains. At the very bottom of that world lies the Mariana Trench, where depth reaches roughly 10.9 to 11 kilometers. Despite the freezing dark and crushing pressure, life persists in the deep. So, what exactly is down there? How did this abyss form? What did the Cold War have to do with its exploration? And what do we really know about the mysterious sounds recorded near its depths? Wind the clock back approximately 180 million years into the Jurassic. Earth's crust moves in colossal plates. In the western Pacific, the Pacific Plate began to dive beneath the Philippine Sea Plate in a process called subduction. Over immense spans of time, that slow, unstoppable motion dragged oceanic crust downward, bending the upper plate into a vast crescent trench, the Mariana Trench. Today it stretches roughly 2,550 kilometers across the seafloor. Its deepest known point, Challenger Deep, sinks to about 10,984 meters. On a map, it's a line. In reality, it's a scar carved by the engine of plate tectonics. How did we learn that? With ships, ropes, and patience. Between 1872 and 1876, the British vessel HMS Challenger sailed nearly 70,000 miles on a landmark scientific expedition, sampling the ocean and taking depth soundings. Crews used weighted lines to measure the abyss, simple, ingenious, and imperfect. In 1875, near Guam, they recorded 4,475 fathoms, about 8,185 meters, an astonishing number for the era. Yes, currents could bend the line and skew results, but those readings hinted at something extraordinary, a deep, hidden chasm in the western Pacific. By the mid-20th century, our tools had evolved. Enter sonar, sound pulses sent downward, their echoes timing the depth. In 1951, a Royal Navy survey, commonly referenced as HMS Challenger 2, scanned the trench with sonar and revealed readings near 10,900 meters. The deepest point would take the first Challenger's name, Challenger Deep. The ocean's lowest place had an address. Reaching it was another problem. At the bottom, the pressure is roughly 1,000 times what we feel at sea level, on the order of a ton of force pressing on every square centimeter. Metal buckles, glass shatters, seals fail. Surviving there requires a different philosophy of engineering. That philosophy became reality in a special kind of craft, the bathyscaphe. Unlike long-range submarines, bathyscaphes are designed to drop straight down, to endure pressure, not to sprint. Swiss physicist Auguste Piccard pioneered the concept. His legacy vessel, the Trieste, was purchased and upgraded by the US Navy in 1958, refitted to probe the hadal depths, the realm below 6,000 meters, named for Hades, guardian of the underworld. On January 23, 1960, the moment arrived. Inside the Trieste were Jacques Piccard, Auguste's son, and Don Walsh of the US Navy. They began their descent. Hours passed. Above them, daylight vanished. Below, the water grew black and still. Temperature fell. The hull creaked faintly, sound traveling through a world of pressure and silence. After roughly 5 hours, Trieste reached the seafloor of Challenger Deep, nearly 11 kilometers down. What did they see? Through a small viewport, fine, soft silt, gently billowing in slow motion, drifting particles, the hint of life adapted to the abyss. Early accounts mention a flat fish, but modern interpretations suggest no bony fish should survive at such pressure. What they glimpsed was more likely deep-sea invertebrates, amphipods or other residents of the hadal zone. Cameras struggled in the stirred-up silt, and time was short. Still, the feet stood. Humans had reached the deepest known point on Earth. It was also a moment of symbolism. In 1957, the Soviet Union stunned the world with Sputnik, the first artificial satellite. 3 years later, the United States could point not up, but down, to the farthest depths of our planet. The Trieste's dive became a quiet counterpoint in a louder contest of prestige. Exploration didn't stop there. Over the decades, engineers sent remotely operated and autonomous vehicles to map, sample and film the trench. In the 21st century, new one-person submersibles returned to the bottom, proving the descent could be repeated. Depth figures vary slightly between missions. Differences in instruments, reference sea level, and local conditions. But the big picture holds. Challenger Deep is the apex of depth. But the trench is not just a number, it's an ecosystem, alien to us but alive. Down there, no sunlight penetrates. Energy arrives as falling organic snow, as chemical reactions in the sediments, as the slow feed of the ocean cycles. Some creatures glow with bioluminescence. Microbes harvest chemical energy in ways that seem almost otherworldly. What counts as extreme for us is simply home for them. Then there are the sounds, the ocean's hidden language. In 1997, the US NOAA recorded a powerful, low-frequency underwater sound in the Pacific that became famous as the Bloop. It was heard across thousands of kilometers. Speculation ran wild. Was it a colossal creature? Years of analysis pointed to a more grounded culprit: ice. The acoustic signature fits the fracture or movement of a large iceberg, an ice quake, not an unknown leviathan. Another enigmatic recording came in late 2014 from west of the Mariana region. First a low hum, then a rising metallic-like twang. At first, researchers were stumped. After months of study, the best match was a minke whale, Balænoptera acuterostrata, producing an unusual seasonal call pattern. Even so, a question lingers: why do such calls appear only at certain times, and why here? Theories involve migration routes, prey availability, even how seafloor topography channels sound. But the deep keeps some answers close. The trench also reminds us that nothing in the ocean is truly isolated from us. Scientists have found traces of microplastics even in the hadal sediments. The circulation of water, the chemistry of carbon, and the life that rises and falls through the water column are all linked to what we do at the surface. The deepest place on Earth is not beyond our reach. It's part of our shared system. So what do we know, really? The Mariana Trench is the long result of plate tectonics at work. Its discovery began with Victorian-era courage and rope soundings sharpened by sonar in the mid-1900s. Trieste opened the door to the hadal zone for humankind. Modern submersibles and robots have widened that door. And the deep's mysteries, from the Bloop to minke calls, teach us that the ocean speaks in many dialects, geology, biology, and physics intertwined. Most of all, the trench is a reminder. Depth is not just a measurement. It's a journey into how Earth works and into what life can overcome. If this dive sparked your curiosity, stay with us. Next time we'll unpack the geology at the trench floor, the traces of life in the sediments, and the technologies that let us touch a world built for pressure and dark. Like the video and subscribe to Eterna Mind, and I'll see you in the deep.